we are going to start the new chapter, that is Unit 13, Hydrocarbons. Now, in this video, we are going to study about the types of organic reactions. Types of organic reactions. Now, we know how to write an ordinary chemical reaction. When we write a chemical reaction, we have reactants reacting together to give the product. Now, when we write an organic reaction, we have, instead of reactants, substrate. Now, reactants and substrate means the same, but in organic reactions, instead of using the word reactant, we use the word substrate. So, let's see how to write an organic reaction first. So, in organic reactions, we have substrate. Substrate means the reactant. Plus, we have attacking reagent. So, substrate plus attacking reagent, and the attacking reagent can be a nucleophile or an electrophile. And you have already learned what are nucleophiles and electrophiles. Nucleophiles are electron-rich species and electrophiles are electron-deficient species. Now, in an organic reaction, we have the substrate reacting with an attacking reagent. First, we get an intermediate product. And this intermediate product formed is unstable. So, it decomposes to give the final product. So, this is how an organic reaction takes place. Substrate plus attacking reagent will give an intermediate product which is unstable. So, it decomposes immediately to give the final product. Now, the organic reactions takes place in several steps, but when we write the organic equation, we see it as a single equation, but actually all organic reactions are taking place in several steps. So, we have something called organic reaction mechanism. So, next we are going to see what is the meaning of the word organic reaction mechanism. Now, I told that organic reactions take place in several steps. Now, what do you understand by the term organic reaction mechanism? The definition is this: a sequential account of each step, details of electron movement, energetics during bone cleavage and bone formation, and the rate of transformation of reactant into products is called organic reaction mechanism. Means when we look at the mechanism of an organic reaction, means we see the different steps taking place in the formation of the product in a particular organic reaction. What all informations we get? We get the details of electron movement, then the energy released or absorbed during bone cleavage or bone making, and also the rate means speed of transformation of reactants into products, and this is what we call organic reaction mechanism. So, it is not possible for us to write the mechanism for an organic reaction by just looking at the organic reaction. So, we have for few reactions the mechanisms to study. Now, any organic reaction, it involves simultaneous breaking and making of a bond. Like our chemical reaction, ordinary chemical reaction, organic reactions also involve breaking and making of a bond. Now, before we discuss about the types of organic reaction, let's see the fission of a covalent bond. So, next we are going to see about fission of a covalent bond. Fission, or we can use the word cleavage of a covalent bond. or breaking of a covalent bond. Now we know that the bond present between carbon, hydrogen or carbon and carbon in organic compounds is covalent in nature. Now there are two ways by which this covalent bond can break. So we are going to see the two ways by which the covalent bond can undergo cleavage or it can break. The first method of breaking of a covalent bond is called heterolytic cleavage. So the first method is heterolytic cleavage or heterolytic fission, or we can also use the word heterolysis. So what do you mean by heterolytic fission or heterolytic cleavage or heterolysis? Now in this heterolytic cleavage, the covalent bond breaks in such a way that both the electron of the shared pair are taken away by one of the bonded atom, and we call this type of bond cleavage as heterolytic cleavage. So I'll give an example. Consider the compound XY. Now suppose Y is more electronegative than X. Y is more electronegative. Now in that case we can see the bond electron pair, this bond electron pair will get shifted to Y because Y is more electronegative than X. Now as a result we can see this bond XY bond breaks and we get the product as X plus Y minus, and we have a lone pair of electron. Lone pair is from this bond. Okay, so this is how heterolytic cleavage takes place. So you can see in heterolytic cleavage the bond electron pair is taken away by the most electronegative atom. It is taken away by only one of the atoms, and as a result we get two species. One is X plus and the other is Y minus. Y minus, along with Y minus we have a lone pair of electron also. Now I'll give an example for this. Suppose we have the substrate as CH3Br. Now in this case heterolytic fission takes place because Br is highly electronegative. So the bond pair will get shifted to bromine and we get the product as CH3 plus Br minus with the lone pair. And we can name this CH3 plus as methyl. CH3 is methyl group, methyl carbonium ion, or you can also name as methyl carbocation. That is carbon carrying positive charge. They are known as carbonium ion or carbocation. Since the alkyl group here is CH3, we call the species as methyl carbonium ion. Now this is one method by which a covalent bond can break, that is heterolytic fission or heterolysis, in which the bonded electron pair is taken away by one of the atoms. Now the second type of bond cleavage is homolytic cleavage or homolysis. So the second type is homolytic cleavage or homolytic fission or homolysis. Now what do you mean by homolytic cleavage? If a covalent bond breaks in such a way that each atom takes away one electron of shared pair, the fission is called homolytic fission or homolysis. So in homolytic fission, the bond pair of electron is taken by each of the atom. We know that one bond pair means two electrons. So one atom will take one electron and the other atom will take the other electron. So here the electron movement is represented by a half-headed arrow because one electron each is taken by both the atoms. So I will show you the example Rx. Now here the bond, covalent bond breaks by homolysis, which means the bond, this bond electron, one electron will be taken by X and the other will be taken by R, and that is represented by a half-headed arrow. Now, this homolysis or homolytic cleavage takes place in the presence of light or heat, and we get the product as free radicals. This is called, R is alkyl group, so we can call this as alkyl free radical. Alkyl free radical. And these free radicals, they are neutral species and they are highly reactive because they contain an unpaired electron called odd electron. So they are highly reactive and they are neutral. Okay, so as a result of homolytic fission or homolysis, the product formed is a free radical. So these are the two types of cleavage of a covalent bond. One is heterolytic cleavage and the second one is homolytic cleavage. As a result of heterolytic cleavage, we get a carbocation and a negatively charged ion with a lone pair. And as a result of homolytic cleavage, we get free radicals as the product. Now next, let us see about the types of organic reactions. So next we have types of organic reactions. Now, mainly we have four types of organic reactions. The first one is substitution reaction. Substitution reaction. Now, what do you mean by a substitution reaction? Reaction in which an atom or group of atoms in a substrate molecule is replaced by another atom or group of atoms. That is called a substitution reaction. And the product obtained as a result of substitution reaction is called substitution product. And the new atom or group that enters the substrate molecule is called the substituent. So, we have substitution reaction, substitution product and substituent. Now, I will give an example. CH3, CH2, Br plus NaOH. Now here Br minus will be replaced by OH minus. So we have the product as CH3, CH2, OH plus NaBr is the product. Now here this is a substitution reaction because Br minus gets replaced or substituted by OH minus. And what is the substitution product? Substitution product is an alcohol with formula CH3CH2OH, and which is the substituent that enters the substrate molecule. The substituent is OH minus and the substrate molecule is CH3CH2Br. This is our substrate molecule, and the attacking reagent is NaOH. In NaOH, OH minus is the attacking reagent. And intermediate is not shown here. Now in all the reactions there is no need to show the intermediate, only the final product is shown in the organic reaction. So this is substitution reaction. Now there are three types of substitution reactions. So we are going to see the types of substitution reaction. The first one is nucleophilic substitution reaction. Now, what are nucleophiles? Nucleophiles are rich in electrons. They carry a lone pair of electrons with them. And what I mean by nucleophilic substitution reaction, the substitution is by a nucleophile. We call it a nucleophilic substitution reaction. And usually, a strong nucleophile will substitute a weak nucleophile. Okay, now in the previous example shown here, CH3CH2Br plus NaOH, OH minus is a strong nucleophile than Br minus. So, OH minus can substitute Br minus. So, that is a nucleophilic substitution reaction. Now the second type of substitution reaction is electrophilic substitution reaction. So B is electrophilic substitution reaction. Now in electrophilic substitution reaction, the substitution is done by an electrophile. And you know what are electrophiles? Electrophiles are electron deficient species. And these electrophilic substitution reactions are commonly found in aromatic compounds. Aromatic compounds means compounds containing benzene ring. Now I will give an example for electrophilic substitution reaction. Example is, this is benzene plus Cl plus. Cl plus is called chloronium ion, and this chloronium ion will act as our electrophile. Now actually this chloronium ion comes from chlorine plus FeCl3. So I am showing that in bracket. From where this chloronium ion is obtained? Chlorine plus FeCl3. And the product is, now in benzene, hydrogen, from any position you can take the hydrogen out. Now what will happen? This hydrogen will be substituted by Cl plus. So what will be the product? You get chlorobenzene plus HCl. From benzene, H plus will come out. It will combine with, it will give rise to H plus ion. So we have chlorobenzene as our product. Okay, so this is substitution. Now here the electrophile chloronium ion substitutes H plus ion of the benzene ring, hydrogen of the benzene, and hydrogen that is removed as H plus ion. So this is electrophilic substitution reaction. Now the third type of substitution reaction is free radical substitution. Free radical substitution reaction. Now free radical substitution reaction means here the attacking reagent will be a free radical, and we know what are free radicals. They are neutral species with an odd electron which are highly reactive. So free radical substitution reactions are commonly found in alkanes. An example for this free radical substitution is halogenation of methane. Halogenation of methane. Now the equations you will learn when you study the properties of alkanes, that is halogenation of methane. That is an example for a free radical substitution reaction. So these are the different types of substitution reactions. That is nucleophilic substitution reaction, electrophilic substitution reaction, and free radical substitution reaction. Now the second type of organic reaction is addition reaction. So Roman numeral 2. That is addition reaction. Now, what do you mean by addition reaction? When the attacking reagent is added to a double or triple bonded carbon atom, we call it an addition reaction. So, addition reactions are mainly for double or triple bonded carbon atom, that is alkenes and alkynes. So, the attacking reagent, the substrate in addition reaction will be an alkene or alkyne. It will combine with the attacking reagent, and what will happen? The double bond or triple bond will break and the attacking reagent will add to the double bonded or triple bonded carbon atom. So, that is addition reaction. Now again, these addition reactions are divided into different types. The first type is nucleophilic addition reaction. So, first type of addition reaction is nucleophilic addition reaction. Now, what do you mean by nucleophilic addition reaction? Here the attacking reagent is a nucleophile, and this reaction is mainly found in aldehydes and ketones. Nucleophilic addition is mainly found in aldehydes and ketones. And the reactions and examples you have in class 12 for the addition reaction in aldehydes and ketones. Okay. Now the second type of addition reaction is electrophilic addition reaction. So the second type is electrophilic addition reactions. And these reactions are mainly found in alkenes and alkynes. The electrophilic electrophilic addition reactions are found in alkenes and alkynes. Now the third type of addition reaction is free radical addition reaction. Now here the attacking reagent will be a free radical. Now example for all these you will learn when you study the properties of alkenes, alkenes and alkynes. Okay, so this is about the second type of organic reaction, that is addition reaction. Three types of addition reaction: nucleophilic addition, electrophilic addition and free radical addition reaction. Now the third type of organic reaction, that is elimination reaction. So Roman numeral 3. That is elimination reactions. Now from the name itself, elimination means some molecule is eliminated from the substrate molecule. Now what do you mean by elimination reactions? Elimination reaction is one in which the substrate molecule loses two atoms from the same carbon or adjacent carbon atom under the influence of an attacking reagent. So the atoms can be removed from the same carbon or adjacent carbon, and this removal of or elimination of a molecule will take place only in the presence of attacking reagent. Now you have one very important elimination, a type of elimination reaction to be studied, that is beta elimination. So under elimination reaction we have beta elimination reaction, or we can also call this as 1,2 elimination reaction. Now you have learned what is alpha carbon, beta carbon, etc. What do you mean by alpha carbon atom? The functional group attached carbon is alpha carbon and beta carbon is the carbon attached to alpha carbon. So here we have beta elimination reaction, and we know alpha, beta, gamma, they are the terms used in common system, and in IUPAC we use numerals. So beta elimination reaction is also known as 1,2 elimination. From the name itself, the atoms are lost from carbon number 1 and carbon number 2. Okay, so we will see what is beta elimination reaction. In beta elimination reaction, when two atoms are lost from adjacent carbon atom of a substrate molecule, resulting in the formation of a double bond, which means it results in the formation of an alkene, it is called beta elimination. So when two atoms are removed from adjacent carbon atom, it results in the formation of a double bond. We call it beta elimination reaction. Now I'll give an example. CH3, CH2, Br. Now the name of this compound is bromo. IUPAC name is bromo. We have two carbon atoms, so bromoethane. This is the IUPAC name. Or the common name is ethyl bromide. Now first let's mark the alpha and beta carbon in this. The alpha carbon is the functional group attached carbon. So this is our alpha carbon. And beta carbon is the carbon attached to alpha carbon. So this is our beta carbon. Now how is beta elimination taking place? By the removal of atoms from adjacent carbon. Now here Here the attacking reagent added is alcoholic KOH. So alcoholic, ALC, alcoholic potassium hydroxide is the attacking reagent added. And we know that KOH remains as K plus and OH minus. And what happens in the presence of alcoholic KOH? The removal of HBr takes place. So HBr, Br is removed from alpha carbon and hydrogen is removed. Any of the hydrogen, because all three hydrogen atom attached to beta carbon is beta hydrogen. So you can remove any of the beta hydrogen. So suppose I remove this beta hydrogen, HBr is removed. Now this Br minus will combine with K plus and we get KBr, and H plus will combine with OH minus and we get H2O. So Br minus will combine with K plus and H plus will combine with OH minus. So let's write the product. The product is, we have, after removing one H plus, we have CH2. Now here double bond instead of single bond, CH2 plus the byproducts are KBr plus H2O, and you can see a double bond is formed and alkene, that is ethene, is our product in this reaction. So this is an example for beta elimination or 1,2 elimination reactions, and more examples you will learn under the properties of alkenes and alkynes. So this is our third type of organic reaction, that is elimination reaction. Now the fourth type and the last type of organic reaction is rearrangement reaction. So next is Roman numeral 4, rearrangement reaction. Now in this type of reaction, some atoms or groups shift from one position to another within the substrate molecule itself, giving a product with a new structure. That is, you get an isomer of the substrate molecule as the product. So I will show one example. CH3, CH2, CH2, CH3. This is butane, 4 carbon atom, plus anhydrous aluminium chloride. Heat. Now the product formed is CH3, CH, CH3, CH3. Now this is an isomer of the substrate molecule butane, and the name of this compound is 2-methyl propane, and you can see same number of carbon and hydrogen in the product, means they are isomers with different structures. So this is rearrangement reaction. Rearrangement reaction means the groups in the substrate molecule or atoms will shift their position within the substrate molecule, and it gives rise to a product which is an isomer of the substrate. So this is rearrangement reaction. So these are the 4 different types of organic reactions that we study in organic chemistry. Thank you.